Hello, ladies and gentlemen. We are going to be doing skill 12B today, which is solving systems of equations with elimination, SAT style. So we're going to look at some sample problems that you'll see on the SAT. So for today's roadmap, you'll want to have your notes out, and we're going to be focusing on two types of questions. One is what I call the K question. And it kind of asks how many solutions are there and deals with that type of question. And then the other one is the variations on the old school algebra systems problems, SAT style. All right, so for the number of solutions questions, we want to be kind of connecting not only the graph, but we like to also be thinking about what it looks like algebraically. So your old school, one solution question, when you do your elimination, you get like the variable equals to a number. So maybe you get like, x equals 7 or something like that. Infinitely many, this is the situation where we have the same line. And this is a situation where maybe we would see something like after performing elimination, 0 equals 0. So that's something that's always said to be true. And then the 0 solutions would be like that parallel line type of situation. And what that would look like algebraically would be 0 equals to, some other number. So that's what things look like algebraically. So if you kind of just do that elimination process that we did, and you arrive at, situations like these, that will help you connect with like one solution, infinitely many solutions, or no solutions. All right, so this is what I like to call the K question, or sometimes they use letters other than K. This is the H that they use. And it says find the value of H for where there will be infinitely many solutions. So our goal is to get 0 equals to 0. So I want to be thinking about when I'm doing some type of elimination. I want to be thinking about what am I going to multiply the top row by so that I can eliminate my x's. And get 0 equals to 0. And I think it's pretty obvious here that if we want to get rid of x, we got to just multiply by 3 and make it negative. So that way we are at negative 3x minus 12y equals to negative 30. And I'm just going to rewrite that other system as well. And what we can see, we want 0 equals 0. And we're almost there, actually, because this negative 3x plus 3x is equal to 0. Our hy plus 12y we want to equal 0. And we want the negative 30 plus 30 equals 0, which we do have. So we need negative 12y plus hy to equal 0. And that means that negative 12y equals to negative hy. And that means that h is equal to 12, making the answer C. Another observation here is we can see that the bottom row is 3 times as big as the top row as well. So some people can even kind of see that pattern, and they can see that 3 times 4 is equal to 12, which does match our answer choice as well. So there are multiple ways of thinking about this problem. Another way that you could even do this problem is just substitute the different h possibilities in and see how it works. So we could do reason numerically. How does top row match with bottom row? And we could also test out different h values. But that does take a little bit more time. But if you find that numerical trick that we were kind of be thinking about, it's a little confusing, I would suggest just trying out the different h values on this one. All right. Another type of questions that you're going to see are kind of like those straightforward systems problems, but in disguise. And the SAT is going to kind of ask you to do a little bit more with the solution sometimes. So this is pretty much a run-of-the-mill elimination problem. In fact, I'd say it's even about a level 1 elimination problem on Delta Math. So we get 10x is equal to 5. And we're going to divide by 10. And it says, what is x? So I get that x is equal to 1/2 or 0.5. And you can just grid in either one of those on the SAT. So the grid in problems, they just ask you to write the answer. And I'm just going to do 0.5. What we're going to kind of see in the next part is just kind of a variation of this type of problem. So we may be asking, like, what is the value of y? So if I want to find y, I could do 3x plus y equals 3. And I could have 3 times 0.5 plus y equals 3. So that's 1.5 plus y. And it's not a bad idea to actually just solve the system completely and kind of get that ordered pair that we kind of had from the old days. And our y value is equal to 1.5. and then our x is 0.5. So our coordinate is going to be 0.5, comma 1.5. Now, the SAT, what they're going to do is they're just going to ask you to do things sometimes with the solutions that are a little bit goofy. But what they kind of just have you do is just kind of reason with your answers and kind of apply the answers to what their question is asking. So we've already answered what is the value of y? So that's 1.5. We already answered, like, if it said, what is the ordered pair? Some people may forget what ordered pair means, but that just means XY coordinate. So that's the 0.5, comma 1.5. That's XY coordinate. X plus Y just asks you to take your X and your Y and add them together. So that would be 0.5 plus 1.5 equals to 2. That could even be like a grid-in type of question. Or I could have 2 times 0.5 plus, I could do like some type of like algebraic expression that could be asked on the SAT as well, where you just plug in your X and your Y into the algebraic expression. So we get 1 plus 4.5, we get 5.5. All right, this question here, this is a sample systems multiple choice question. And it says y equals to 2x and 3x plus y equals to 20. It looks like it could be an elimination, but the problem is that the x's are not kind of aligned. But if we did, let's say, negative 2x plus y equals 0, so I just moved the x over to the other side, and then I had 3x plus y equals to 20. If I actually just multiply that by a negative, I could get those y's to eliminate really nicely. So I have, on top, negative 2x plus y equals to 0. And then on the bottom, I have negative 3x minus y equals to negative 20. And these kind of cross out. So actually, they don't cross out. Let me just undo that. The y's cross out. So we can cancel that, and I have negative 5x equals to negative 20. Just divide by negative 5. And lo and behold, we have our value of x, which is equal to 4. Another thing that you could do is you could just plug in your answer choices as well. So like, let's say you plugged in 4. So if I did y equals to 2 times 4, that is equal to 8. So I know that y is equal to 8. And then I could have 3 times 4 plus 8, and I could see if that equals to 20, which in fact it does. So you could actually save a little time just plugging in your answer choices real quick to see if they work. So that is our last example on the notes. During class time, we will have a little bit of some U-try as well, just to kind of check your work on how you're processing these SAT style questions.